Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on September 10th, 2025, just yesterday. The standout result is that a balanced sharing scheme, where each node mixes 4 local and 4 external rollouts, delivered the highest accumulated reward, a 94% improvement over the no-sharing baseline. The paper is titled, Sharing is Caring, Efficient LM Post-Training with Collective RL Experience Sharing, and the implications for model training are quite significant. In short, this paper introduces a decentralized reinforcement learning method that shares decoded experiences across heterogeneous nodes, improving small model reasoning while avoiding centralized bottlenecks. On X, posts frame SAPO as a decentralized reinforcement learning breakthrough that shares experiences across nodes, speeds learning, and deserves upvotes on trending lists, with one launch tweet drawing 178 likes indicating strong engagement. Alright, the previous figure highlighted the benefits of balanced sharing. Table 1 presents the SAPO procedure, which runs each node independently while exchanging decoded experiences. The table shows nodes sampling questions, generating multiple rollouts, and broadcasting a selected subset with metadata so peers can reuse it. The training set then mixes self-samples and external samples, controlled by 2 knobs that set local and external counts, and a policy gradient update closes each round. This structure explains why insights spread quickly without synchronization. Alright, the previous table outlined the round structure and the sharing knobs. Figure 1 compares reward trajectories across 4 sharing mixes, which clarifies how external rollouts change both peaks and stability. The balanced 4 local and 4 external setting shows strong gains without wild swings, so cumulative reward climbs steadily. The 2 local and 6 external setting spikes higher but oscillates, which suggests noisy shared data from weaker peers. The no-sharing baseline grows slowly with low peaks. Alright, the previous figure contrasted stability across sharing mixes. Figure 2 presents smoothed average rewards over training steps for 4 configurations, which highlights how mixing local and external rollouts changes learning speed and reliability. The 4 local and 4 external line stays above the others for most of training, so expected reward improves consistently. The 2 local and 6 external line peaks higher but shows large oscillations, indicating unstable shared data. The no-sharing baseline remains lowest throughout. So the previous figure showed smoother learning with balanced sharing. Figure 3 compares QN 2.50.5 billion trained in the swarm versus the isolated baseline, plotting cumulative rewards over normalized rounds. The blue swarm curve rises steadily and surpasses the orange baseline by a wide margin, which signals faster learning and higher payoff per round. The shaded red band indicates rounds where differences were not yet statistically significant. After roughly 175 rounds, significance holds and the gap keeps widening as training runs accumulate. Okay, 2 takeaways stand out. Balanced sharing of experiences across nodes roughly doubles cumulative reward while staying stable, and lightweight decoded sharing lets small models learn faster without centralized orchestration. The broader implication is practical decentralized reinforcement learning that scales across messy, heterogeneous hardware and models. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.